Hello. Now we are going to look at some of the things that we can do with functions, or the operations that we can do with functions. To begin with, we're going to remind ourselves of what functions are. So a function is a machine that takes an input, which we would have as our x values most of the time. So our x's here for f of x are the inputs, and then the function output is the output of f of x. So all of this is the output of the function. So we input a value for x, say x is 1, and we would square that number and subtract 4 from it, and then that whole thing is the output of the machine. We input x is 1, and the machine outputs what happens when you square 1 and subtract 4 from it. So that's the meaning of our function. We have another function here, g of x. So the function g, when we input x, we triple that number and subtract 6 from it. That's what the function, or the machine, g of x does. Now we can also see this function notation written a little bit differently. This is the same function f as before, but it's written in a different style. So this is read as the function called f does the following. It takes in the input x and it sends it to, the operation it does is square x and subtract 4 from it. So this is the input to f, this is the output of f. And if we just give an example using our function diagrams, this would be the input numbers, the domain, and this would be the range. So if we input 1, we square 1 and subtract 3 from it, and we end up with the output of the function being minus 3. So you input 1, you output minus 3. If you input 2, you square 2 and subtract 4 from it, and you end up with 0. So the input to the function f is 2, and that will give the output from the machine, or the function f, is 0 when x is 2. Now, let's put this into practice. If we have f of minus 1, that means our input is minus 1. So what is the output of the function when the input is minus 1? So when the x value is minus 1. If we were graphing these things, we would be looking for the output of the function would be the y coordinate. So we put the input numbers are our x values, the output numbers when we are graphing it would be our y coordinates, our y values. So in this case, x is minus 1. So we're going to have x is minus 1 to be squared minus 4. Minus 1 squared means minus 1 times minus 1, minus 4. So we end up with 1 minus 4 is equal to minus 3, which we got for 1 as well. Because this is a quadratic function, we end up getting the same thing for minus 1 and plus 1, because it's symmetric around its minimum, which is x is 0. So g of x is equal to 6. What does that mean? It means the output of our function is 6. So this effectively implies the question. What value of x, what input to the function g, would result in the output being 6? Well, we can describe g of x as 3 times a number minus 6, and we know that that should end up equaling 6. So now we can rearrange this equation to find the value of x that would make that true. So if we're asked a question like this, we're told g of x is equal to 6, or anything is equal to a number, we can say, well, I know what that function is, so I can write that down and then solve the equation. So I rearrange my equation to find out the value of x that would make this statement true. So 3 of x would be 12, divide both sides by 3 to get 1 of x. To get 1 of x would be equal to 4. So g of 4, if we input 4 into the function, we should get 6. So if we had 3 by 4 is 12, minus 6 is 6. So the function works out that way. Now, f of x is equal to g of x. This is asking what value of x, or is there a value of x, the same input number, the same x value, would give the same y output. And in essence, this is asking for the intersection of our two functions. So f of x, we know what that means. That's x squared minus 4. And when would that, what value of x would make that equal to 3x minus 6? And immediately I see I have a quadratic, so I'm going to try and rearrange that and solve. So I need to get everything equal to 0, and then I will try to factorize plus 6 plus 6. Get everything equal to 0, so I end up with x squared minus 3x plus 2 is equal to 0. If I couldn't see how to factorize this, I would be able to use the minus b formula to do it. So I would have ax squared plus bx plus c is equal to 0 and use my minus b formula to solve it. But I want to try and do factorizing first. So I'd have 1 by 2 would be 2. What factor pairs of 2 would add up to minus 3 is a way of factorizing this. And we would have minus 2x minus 1x will work. So we're just factorizing quadratics and we end up with taking our common factors out, and we end up with x minus 2 as our common factor in our bracket, and we have those two multiplied together equals 0. Now that allows us to say this times this is equal to 0. So if this bracket was 0, this would be true. If this bracket was 0, this would be true. So we can break that up and say x minus 2 could be equal to 0, or x minus 1 being equal to 0. Either of those things being true would make that equation true. So we're able to rearrange our equations in order to get x is equal to 2 and x is equal to 1. So when x is equal to 2, this statement would be true. When x is equal to 1, this statement would be true. So if we had x is 2, we'd have 2 squared is 4 minus 4 is 0, and you would have 3 by 2 is 6 minus 6 is 0. So we get 0 equals 0. Or when x is 1, you'd have 1 squared minus 4 is minus 3, and 3 by 1 is 3 minus 6 is minus 3. So we see these two values of x make this relationship true, that x squared minus 4 is equal to 3x minus 6. So we can also get unusual things to sub into our function. So g of 2m minus 1 behaves exactly the same way as when we did f of minus 1. The input to our function is 2m minus 1. And the fact that that looks complicated relative to minus 1 doesn't matter. We're just going to say the input to this function is now going to be 2m minus 1. So anywhere there was an input to my function, I'm going to put in 2m minus 1. And as always, sub in everything in brackets. Now you just tidy this up. So we have three groups of this, so you'd end up with 6m minus 3 minus 6, so you'd end up with 6m minus 9. So that's when we put input 2m minus 1 into our g of x function, that's going to be the output of that function. Now this kind of looks like a function unto itself, and that leads on to what we call composite functions. So a composite function is where we have, or a composite function is the way it's sometimes pronounced, is where we have functions inside of functions, in the same way as composite materials are made up of two distinct materials or multiple distinct materials. We have composite functions are where we have one function inside of another. So we're going to have a look at g of f of x. So what we're going to read here is we have g is the outer function. So we have effectively got, kind of like what we had here, we have g, and inside the brackets of g, we have f of x. So this function is what is going to get subbed in as the input to g. Now this can be written in two different ways, or in three different ways. It can be written like this, which is often the clearest way to read it, because g is the input to f is the input, x is the input to f is the input to g, I should say. It can also just be written with left to right, so g, f, x means the same thing. F is inside of g. It can also be written with a little circle symbol in between, so g of f of x. So we can sub in. So anywhere there was an input in g, we're now going to put in the definition of f of x. So this is going to be 3, oops, I'll change our color. So we're going to have 3 on f of x minus 6. Again, this is just the f of x function that is being substituted in as the input to the g of x function. So now you just simplify that function out. We have 3 of these things, so we'd have 3x squared minus 3 groups of minus 4, 3 groups of minus 4 is minus 12, minus 6. So you end up with 3x squared minus 18. We can also go the other way around. We have f of g of x or fg of x, and you just sub in the same way. Now we'd have x squared. So we're going to have 3x minus 6 to be squared minus 4. So this is the g of x. And now we're just going to multiply this out. So we're squaring a bracket means multiply the thing by itself 2 times. We just multiply out that bracket and tidy up. We have 3x groups of 3x minus 6 groups of 3x minus 6, and we still have minus 4 units on the end. We end up with some like terms and we add them all up, and that is going to be our f of g of x. So what would g of f of 2 mean? Well, you'd get g of f of x, which we already did. It's 3x squared minus 18. And then we'd say, what happens when x is 2? Well, we've already done this part of it, so we can just sub in and say 3 on the input now. The x squared is going to be 2 squared minus 18. So you end up with 3 by 2 by 2 minus 18. So you end up with 12 minus 18, so you end up with minus 6. So those are some operations or some things that we can do with functions, and that is what we need for now.